Hello, I hope all of you are doing well. In this video, we are going to talk about the concept of segmentation. So what happens is in the concept of segmentation, it basically helps you for again non-contiguous memory allocation only, but it's a slight difference from paging. So what happens in terms of concept of paging, it is generally understood that segmentation as a paging, as a technique is very close to how an operating system view is generated, okay? But it is actually very far from how a particular user understands a process, understands a program, okay? So what we do is in a segmentation kind of a technique, we try to understand the entire idea of non-contiguous memory allocation from and try to bring that view more close to a user. Okay, so what happens is instead of in this every process being divided into, I would say, pages, it is actually divided into segments. Okay, so the memory basically gets divided into segments. Okay, but there is a difference over here. Paging was basically having pages of fixed size. Segments over here has different size. For example, let's say here you have a program. Okay, in the program, let's say one segment is the main function. Okay, one segment is basically where you have, let's say, a minimum function inside it. Okay, one function is, let's say, where exactly all the stack memory is available. Okay, one area is where you have all the objects available. So these are all what segments are. Okay, earlier when you were just dividing it into fixed size pages, operating system could understand it, but it was difficult for user to understand it. But here when you understand it or do it in terms of segments, where each part of a function or a method, object, stack, arrays, anything could be divided into different segments. Hence, obviously, it means also that segments are of variable size, because the minimum function could be small, the main function could be big, anything can happen, correct? So in that case, what we do is we basically apply the concept of segmentation, in which the size of each and every segment is different. And whenever a process is supposed to be executed, right, its corresponding segments are loaded into the non-contiguous memory. Okay. So always remember how we are going to actually table you were using a paging. Here in segmentation, we basically use a segment table. Okay, and this is the basically the memory where everything is available. Here one more important concept is base and limit. Okay, so base is basically the position where your particular segment is starting to be stored. Okay, let's say I'm starting it over here, so this basically becomes my I would say the base address over here. Okay, if I'm starting, let's say, as 1400. Okay, so let's say this is 1400 and limit is, let's say, 300. That means for 300 more, basically this segment is present. That means it is ending at 1700. If I do, let's say, 2200 and here it is 500, that means the base where this segment starts. Okay, here we have segment number also. Here the base where this segment starts is at 2200 and it takes 500 over here. That means it is ending at 2700. So base is the base address where the segment is stored in the memory, right? And limit is basically how below we basically want to do to drive that. Okay. So how does it basically work is, whenever you have a CPU now which wants to access the memory, it first generates the logical address. The logical address over here will be the segment number, right? And this will be the offset, right? Which is like this offset, right? Here, if it is 1400, let's say you want to read something at 1480, okay? Or let's say, so this is like the offset of how you want to go low. So whenever you get a segment number, you are going to directly go to the segment table and find the corresponding segment, like the area in the memory which is it stored. So let's say here it was segment number 1, or here this was 1. So you basically find out that the base is 1400, okay? Now this is the offset. Okay, that means what really do you want to access in that segment. So here, before actually directly going to the segment part, you have to do a match over here. For example, this was 1400 and here the limit was 300. That means the segment was available from 1400 to 700 and the offset that you mentioned over here was 500. Okay, which is wrong, right? Because here offset 500 means that we are trying to access something at 1900 and the range of that segment is not that much. So what we do is we try to do a check over here first, that if the segment number is less than the limit over here. Okay, and if that is actually true, right, then what we do is we basically add the value of the segment number with the offset and simply go ahead and read the data. Okay, so this kind of a view is very, very close to, I would say, what the actual view of how a user understands the code is, and this is how the entire concept of segmentation works. Okay, so segment table is basically used to keep the record of the segments. Okay, and trust me, here segmentation in which we use segment table, it takes less space compared to the paging table. So it is definitely an advantage over here. Secondly, there is no internal fragmentation. In paging, you did not have external fragmentation and no internal fragmentation, and you had internal fragmentation. Here with this technique, you will not have internal fragmentation as well, because wahan par the pages were of fixed size, correct? Here, the segments are of variable size. Okay, so the segmentation technique allows you to take a program and divide it into different modules for better visualization for the user. Okay, how the user can actually understand how different visualization is done. And then we say that the segments are of variable size. Okay, that is what the overall idea of segmentation is. Okay, segmentation memory management works very similar to paging, but here segments are of variable length, whereas in paging, pages are of fixed size. A program segment basically contains the main function. Okay, like whenever you have a program, you divide it into segments could be like a main function, one segment, utility function could be another segment, data structures could be in a part of separate segments, and so on. Okay, and the operating system maintains a segment map table for every process. So the segment map table is different for every process, and also a list of free memory blocks along with those segment numbers, their corresponding site and their corresponding location in the memory. Okay, so this is how we understand the concept of segmentation. Okay, so please don't get confused between paging and segmentation. It can look similar, and it is actually, I would say, somewhat similar in some ideas as well, but actually both the techniques are different in terms of how do they divide a process, and then automatically the rest of the part also becomes different. Okay, all right, then I hope this is clear to everyone. Right? In the next video, we are going to talk about the last way of contiguous memory allocation. Thank you.